Alright, so solving linear equations. So we can solve linear equations with one solution, no solution, or infinitely many solutions. So solving an equation means finding the solution, obviously, of the variable in the equation that makes the statement true. We want to isolate, so get the variable on its own, in order to solve the equation. We usually move the variable to the left, but either side works. Okay, so when we're doing this today, we're going to add the properties in here of what we're actually doing. So we've got the addition, subtraction, multiplication, and division property of equality. All that means, if you have a statement where A equals B for the addition one, in order for them to stay the same, you have to add the same thing to both sides. So that's the important part. You've got to do the same thing to both sides. So you're either adding the same thing, you're subtracting the same thing, you're multiplying the same thing, or you're dividing the same thing to both sides. Everybody knows the distributive property. It's literally just taking this A on the outside here and multiplying it by everything on the inside. Super important. Sometimes we forget to multiply everything. Okay, this first example. Isolate the following general linear equations for x, and then stating which property was used for each step. Alright, so point slope form. We're going to isolate for x. So first things first, we try to get to this x. We want to get rid of this m. And we divide both sides by m, and that takes care of that part. This is the division property of equality. The division property of equality. So then we're left with y minus y sub 1 over m equals x minus x sub 1. Now we have to get x on its own, so we just have to get rid of this piece here. So we're not actually going to get any numbers in this answer, we're just going to rearrange and get a bunch of letters left over, but with just the x on its own. So we're adding it, so we're literally just adding it to both sides. And that second property is the addition property of equality. So nothing too tricky here. Just remember, we're rearranging a bunch of letters. This is slope-intercept form. We're going to isolate for x. So first thing we want to do is move this b to the other side. So we'll have y minus b equals mx. That's the subtraction property. Subtraction property of equality. And then we want to get x on its own, and the only way we can get x on its own, the m is multiplying it, so we're going to divide both sides, therefore x equals y minus b over m. And that's the division property, so the division property of equality. And the spelling is just up here. We've got transformational form. We're trying to isolate for x. So first things first, we have to get rid of this k. So we're going to subtract k from both sides. So that means on this left side we get y minus k equals a times the quantity x minus h. The only way we can get into this parenthesis is to get rid of this a. So we're going to divide both sides by a. So we started with the subtraction property of equality. And then the division property of equality. So this leaves me dividing both sides by a with y minus k over a equals just x minus h, because we divided them out and was left with just the x minus h. And then from here we just have to add. So we're going to add h to both sides. And that gives us x equals y minus k divided by a plus h, and we added, so that's the addition property. Remember, of equality just means you're doing it to both sides. Okay, and the standard form here, we're trying to isolate for x, so we want to move over this by. So first I'm going to subtract both sides by by, so we're left with ax equals c minus by. Again, it's kind of nonsense. What we're trying to look at here is what the properties are. So we're not going to get any numbers, we're just going to get a bunch of letters. So subtraction property of equality. And then we have to get rid of the a, so we're dividing both sides by a, leaving us with x equals C minus B divided by A. And that's the division property of equality. Okay, do a little bit more of this. This example here, isolate the following equations or formulas for the indicated variable. So we have Z equals MB over A, and we're looking for A. So we want to get A in its own. So first things first is we have to get it out of this denominator, and all we have to do is multiply both sides by A. So we have AZ equals, if I multiply this side by A, then the A's will divide out and you're left with just MB. Now it's not asking us for the properties in this, we're just rearranging. And then we want to get A on its own, so now we just have to divide both sides by the Z, and that leaves us with MB over C. This next one we're trying to find, now we're trying to get, there's two A's, so first thing we have to do here is get both of the A's together. So we've got KA, we're moving this over so we're going to subtract, so minus BA equals V plus W. So we're trying to get A on its own, so what we're going to do is a little trick here, we're going to factor out an A. So if we take an A out of the first term, we're left with a K. If we take an A out of this, we're left with a B. So remember, if we just distribute this back in, A times K is KA, A times B is BA. Goes V plus W. And then now to get rid of this K minus B, we're just going to divide both sides by this K minus B. It divides out here, left with just A, and we have B plus W over K minus B. So we're just manipulating the letters. We're going to solve for X. So here we're going to try to bring together as many things are away from here as we possibly can. So we're going to move this over. So that these look the same, but they're different. This is a V sub 0 on it. It's got a sub 0, which this doesn't. So we've got 2A times X minus X sub 0. We're trying to get to this parenthesis, so we're going to divide both sides by 2A. So we've got B squared minus V sub 0 squared over 2A equals X minus X sub 0. We're trying to get this X on its own, so we have to get rid of this. So we're going to add X sub 0 to both sides. And we're left with X equals B squared minus V sub 0 squared over 2A plus X sub 0. Okay. Now let's do this with some numbers and letters. So isolate for the following linear equations for the variables, state the property used, and then check your answer. So 3 parts here. So first things first. Let's put together any like terms, kind of simplify this a little bit. So on this side, we know these are like terms, so they become negative 10a. Just put them together. Minus 6 equals negative 7a. So the property used, we're going to call it, we're going to simplify it, write it as combine like terms, but we're going to simplify this as CLT to make it a little bit quicker. And I'm going to move over this 7a, so I'm going to add 7a to both sides. And that gives me negative 3a minus 6 equals 12. So, oops. Addition property. Of equality. So addition property of equality. I'm going to move this 6 over. So I'm going to, it's subtracting, so I'm going to add it to both sides. And I have negative 3a equals 18. This is also the addition property of equality, so I'm going to leave that for this line. And then all I have to do now is get rid of this negative 3, and it's multiplying to divide both sides by negative 3. And that gives me a equals negative 6. And that was the division property of equality. So we isolated the variable. We stated our properties, and now we just have to check your answer. So this part's not too difficult, we just have to substitute it back in. So negative 8, and what we think our answer is negative 6. 6 equals negative 2 times negative 6. Oops, I mean to put, sorry. Minus 2 times negative 6, and then the other side going to be negative 7 times negative 6 plus 12. I want to set both sides equal each other. So negative 8 times negative 6 is 48. Minus 6. Negative 2 times negative 6 is plus 12. 48 minus 6 plus 12 is 54. On this side we have 42 plus 12, and that's also 54. So correct. This is your final solution. This next one here, we have trying to get our like terms together. So we notice there's some fractions here, so we can get rid of the fractions. This is a much easier problem. Common denominator of 4 and 8. Common denominator is the lowest common multiple, so that's going to be 8. So we're going to multiply everything by 8, because if I multiply by 8, it gets rid of this denominator, and then it also takes care of this one as well. So that's going to be 2 times 8, which is 16, minus 8 times 3 over 4. We'll come back and deal with this in a second. Equals 1/8 of 8 is just 1, so 1z, plus 9 times 8 is 72. This part here, if we treat it as 8 over 1, then we can cancel out here, and 8 over 4 becomes 2 over 1, and then 2 times 3 is 6. So 16 minus 6z equals z plus 72. Okay, so now let's go ahead and, let's just clear the fractions here. Let's go ahead and solve this. We want to get our like terms together, so I'm going to actually subtract z from both sides. And I will have negative 7z, and I'm going to move this 16 over, so I'm going to subtract 16 to this side as well. 72 minus 16 gives me 56. So that was the subtraction property of equality. And then divide both sides by negative 7. And that gives us z equals negative 8. And that was the division property of equality. And then we just have to put it back in and check. So we've got 2 minus 3/4 times negative 8. Change that color. Hopefully that's going to equal 1/8 times the negative 8 plus 9. We'll check both sides are the same. So we have 2 minus, now if we put this over 1, again the 8 and the 4, that'll give me a 2 and a 1, but don't forget that's negative, so negative 2. And negative 3 times negative 2 is going to be positive 6. And then this side here, we get 1/8 of negative 8, so that's negative 1 plus 9. This side is 8, and this side is also 8. So answer z equals negative 8. Okay, next one. So we need to use a distributive property here. We get negative 12 minus 18a equals negative 6a. Get to distribute into both parts, or all parts of the parenthesis. This is the distributive property. If you forget to multiply into both parts, then it messes up your answer. Alright, so we want to get all our like terms together. So first thing, leave this on this side for the moment. Let's combine the like terms on this left side here. Sorry, right side. Negative 6 and negative 12 is negative 18. So and I want to move the 18a over to the other side. I'm going to add 18a to both sides. And that will actually give me 0 here. And negative 12 plus 0 equals 3, 0. Now negative 12 is left equaling 0. That doesn't work. So this is a false statement because your letters or variables all cancelled out, which means there's no solution. In terms of properties, I combine like terms here. And then I did the addition property. Addition property of equality. Okay, there are a couple more problems. Here we're going to again distribute. We get negative 14b plus 28 equals negative 10b plus 30. So first step, distributive property. There's no like terms on the same side, so we're going to just have to move things over. I'm going to move this 10b over, so move the letters to the left, and then move the numbers to the right. So that gives me negative 4b here. Disappears, this disappears, and then we put those together equals 2. And watch this part here, we've got to get the negative, the b on its own, so we're going to divide both sides by negative 4. Which leaves us with b equals, this is 2 over 4, which is 1 over 2 when you simplify, and don't forget it's negative. So that was the addition, and we'll put both of these together, and subtraction property of equality. And then in terms of checking, we've got negative 7 times 2, that's negative 1/2 minus 4. I'm going to show that 5 times negative 2 times, or negative 1/2. I'll come back to that in a second. Change colour. So negative 1/2, not as hard to deal with because it's 2 times negative 1/2. We'll check that both sides are the same. So it's negative 7 times negative 1 minus 4. Negative 7 times negative 5, so positive 35. On this right side, we have 5 times, this becomes positive 1 plus 6, and then 5 times 7 is also 35, so correct. Right. And then I believe this is our last problem. Then we're just going to distribute. Okay. So let's distribute here. We have 2a minus 16 plus 7 equals 5a plus 10 minus 3a minus 19. So I've just distributed. So property used is distributive property. And then let's simplify this left side. We're going to have the negative 16 and the 7 together, giving me negative 9. I'm putting together the 5 and the 3 and 2a, and the 10 minus 19 is also negative 9. Now what's going to happen here is I'm going to subtract the negative 2a, this will cancel. If I add the positive 9, this will cancel, and everything cancels out, so you're left with 0 equals 0, which is a true statement, which means there's infinite many solutions. Infinitely many solutions. And we did the combine like terms, and then the addition and subtraction property of equality. Okay, the video is a little bit longer, but it's got a lot of properties to write out, but in general it's not a lot of difficult stuff, which is nice.